welcome back. Today we are going to switch gears in algebra and we are going to start solving simple equations. Okay, so the first thing that we want to know is the difference between an expression and an equation. So this one here on the left, notice, doesn't have an equals in it. If we were simplifying it, we would have equals on the next line, and this one is actually called an expression. Okay, and that's what we've been working with before in collecting like terms, okay, and simplifying algebraic expressions. But now we're going to take a look at these ones right over here that have an equals already in them. And these ones are called equations. Okay, and to solve an equation like this one on the right means to find the value of x that makes this equation true. Okay, and you've learned this before. You started learning how to solve for x in elementary school. And today we're just going to sort of formalize that process so that you are able to make things more complicated and do more complicated equations. So the main idea here is that we do this by isolating the variable on one side of the equation. So isolating this x onto one side of the equation. And what we do is we use inverse mathematical operations, okay? So you might recall before that if we have, let's say, an addition, the inverse or the opposite operation to that would, of course, be a subtraction, right? Those are opposite operations. And then similarly, we might have a multiplication going on, and the opposite operation to that would, of course, be a division. Okay, so those are considered opposite operations. Adding and subtracting is an opposite operation, and multiplying and dividing is an opposite operation. So we use opposite operations to isolate the variable, and we actually use opposite operations even in the opposite order of BEDMAS, okay? Meaning that we deal with our addition and subtraction first, okay? And then we deal with our multiplication and division last. And I'll show you what I mean on the next slide. Okay, so here we go with our first example. Okay, we'll look at this one right here and note that's a -7 there. And again, the idea is we're trying to isolate and solve for x. Now, a lot of you will be able to do these ones in your head. A lot of you will have been taught many different ways to do this in elementary school. So you're going to pay particular attention to how we do this in grade 9. Okay, so the main idea, like I said, is we want to isolate this x. We need to move this +5. It's an imaginary +5. And basically to do that, as you know, we subtract 5 from both sides. So we have this 5 plus x. We have this equals -7. And we know that we can get rid of this 5 if we subtract 5 from here. And then it's that idea that we are creating a balance here. Whatever you do to one side of the equal sign, you must do to the other. So we subtract 5 over here. Okay, on the left, of course, these 5s sort of cancel each other out. 5 minus 5, we are simply left with x. And then on the right-hand side, we now have -7 minus 5, which of course gives us -12. Okay, so that's sort of what you've been taught before. Sometimes maybe you write that -5 there. Sometimes maybe you write it here. Okay, I want to show you quickly what I'm looking for you to be able to write in grade 9. Okay, so if we just do a little line, I want to show you what my next line would be. And when we practice, we're going to try to practice using this idea. Okay, so like we said, we recognize we need to move that 5. Okay, we want x by itself on the left. On the right, we already have a -7. And basically, the idea is that this +5 over here gets moved to the right. It gets subtracted to the right. And so we literally write subtract 5 on the right. So we don't write it on both sides. We just write it like that. And then we simplify. We get x equals -12. So when we practice, we're going to start practicing using this blue idea. Okay, so similarly, let's see if we can try the next one. Okay, so in the next one, we have our x right here. We know we want to isolate it. We know we want to move this subtract 8 or this negative 8. So when we move it to the other side, what happens is we end up adding 8 on the other side, okay? So again, in elementary school, you might have written something like this. Okay, and then we would add 8 to get rid of the minus 8. So whatever we do to one side, we have to do to the other. So we would get something like this, and we would get 14. Okay, in high school, what I'd really like you to be able to write here is we're going to leave the x on the left. We have a 6 on the right, and then basically this negative 8 moves over to the right, and it becomes an add 8 or a plus 8. And of course, then we simplify, and 6 plus 8 is 14. Okay, so that's the idea that we're going to practice. We're going to practice it, writing it exactly the way I've written it in the blue. So if you can please write it in your notes in the blue, that would be really helpful. Okay, now let's try some other ones. Okay, so you'll notice in question C here, okay, again, we want to isolate our x. Okay, this means we want to get rid of that 3 right there, okay, and it currently is being divided, so we do the opposite operation, which of course means to multiply. So we have our x over 3 on the left, we have our negative 5 on the right, so what we want to do is we want to multiply both sides by 3. So maybe in elementary school you wrote it like this, or with a little times symbol, we want to multiply both sides by 3, and then what ends up happening, these 3's cancel, and we get x equals negative 5 times 3 is negative 15, okay? So again, going back to this idea that here's what we're going to do, okay? We have x divided by 3 equals negative 5. We want to move this 3. It's being divided, so we simply do the opposite on the other side. We multiply it to the other side, okay? And negative 5 times 3 again is negative 15, okay? And please remember, of course, that we can check every single one of these answers, okay? So to check, remember, we're saying that x equals negative 15. So if we take negative 15 and we sub it in here for x, we get negative 15 divided by 3, which is negative 5. Of course, left side equals the right side, so we know we're good. Okay, so a lot of times you're not going to see answers posted on this because you should be able to check your answers. Okay, again, we're looking to write this blue stuff right here. Okay, let's try one more. Here we're trying to isolate the x. Okay, we want to move the negative 4. The current operation is multiplication that is going on between the two. So this is where we will divide the negative 4 to the other side, okay? And this is where in elementary school, a lot of times you write this, okay? These negative 4's cancel, and so you end up with x equals 32 divided by negative 4, which is negative 8. Okay, again, let's try and simplify this process just a little bit. We want to move this negative 4. It's being multiplied. So we're going to divide it onto the other side. Okay, opposite of multiplication is division. And then, of course, x equals negative 8. Here's our blue. Here's what I want you to be writing. Okay, so if you can try some of these, I've got 2 here on the next slide. So I want you to pause the video, I want you to write them down, I want you to try them, and then I want you to bring them to class and see if you can get them right. Here they are. Okay, so both of these 2 right here, I would like you to try them, so I want you to write them in your notes. I want you to try them, and then I want you to come ready to show me if you can understand this video and if you can get these 2 right. Okay, and we'll see you later. Thanks.